Good morning to all of you. Today I am going to the subject transforms and partial differential equation, second year, third semester, agriculture and food technology department. Wait to the topic a case study on one dimensional heat equation analysis of industrial waste heat by heat pumps. Introduction. Heat pumps and solar thermal energy suppliers are important technologies to increase the share of renewable heat in industrial process. Yes, they contribute to the climate target. They play an important role in European guidelines as well as in national regulations. In ambitious scenarios, energy efficiency measures and enhanced use of renewable energy in industry have the potential to reduce global emissions by 66% by 2030. The aim is to identify the processes that are suitable for the integration of heat pumps and solar heat. The reduction and integration of waste heat streams is an essential step to increase energy efficiency industry. The industrial process that have great relevance to contributions to the country's climate targets that reduce the greenhouse gas emissions by 40% and increasing energy efficiency renewable energy by 27% by 2030. Reducing waste heat streams is an important measure to increase energy efficiency in industry. A number of processes, such as drying processes, generate humid exhaust gas streams that are currently vented without any future use. Those waste streams can be valorized by heat pumps. In this work, three case studies, a paper in this work, we have to three case studies by we have to take the one case studies. A humid gas streams, the heat source for heat pumps are developed. The concepts are evaluated by technical, economic assessments to quantify the effects in terms of energy, emissions, and cost savings. In all cases, the integration of heat pump is an environmentally sound measure. Energy cost savings depend on the individual conditions of the case study and are often a limiting factor of valorization carbon dioxide emissions reduces reductions as it is intended in the emission trading system will have a strong positive effect on heat recovery with heat pumps. Next one, method of process of analysis. Methodology, process analysis. To find untapped waste heat potentials, a detailed process analysis was carried out in 12 different industrial companies. European standards carry out the energy audits is in accordance in the energy efficiency directive. Based on that standard, the energy supply and consumption of the processes was analyzed to determine the energy demand of the processes, the possibilities for processes and system optimization and integration of heat pumps and solar thermal energy. And next one, flow sheet simulation. Flow sheet simulations was used to calculate the process parameters before and after heat pump integration. The simulation tool IPSE Pro was applied, which is well studied for industrial processes. It uses an equation oriented solver for the calculation of mass and energy balance of stationary processes. The setup implemented in IPSE Pro corresponds to the actual setup of the different processes. The units of the process, gas boiler, heat exchangers, dryers, etc., are connected by streams that transfer mass energy. The Process units are balanced according to conservation of mass and energy. Mass and energy balances are strictly fulfilled for all process units. For the simulation, a simplified heat pump model was developed by AIT. The model uses the temperature of the heat source and sink and a Carnot efficiency factor to calculate the power consumption, heat input and heat output of the heat pump. It is not necessary to specify the refrigerant or type of compressor in this model. So it can be used to potential assessment in a wide range of temperatures. The Carnot efficiency factor was chosen at the 0.50 because the experiments with a laboratory prototype of a high temperature heat pump have shown that this factor can be expected with an optimized heat pump. The main process parameter in the simulations are the temperature, humidity, and mass flow of the exhaust gas that are either measured in the process or calculated with IPSE Pro in a mass and energy balance. The temperature of the intended heat sink is also required. Next one, techno-economic analysis. Techno-economic analysis. The simulations results provide the basis for the techno-economic analysis potential reduction in carbon dioxide emissions and energy and primary energy consumption are calculated by comparing the original process of the steam boilers fired by natural gases process with the heat pump. The heat is supplied by steam boilers fired by natural gas. With the use of the heat pump, natural gas consumption is reduced by electricity is needed for the compressor. The carbon dioxide emission factor relates the amount of carbon dioxide emitted into the atmosphere to the end energy available as per process heat. Other greenhouse gases such as methane are also considered. The primary energy factors shows how much energy is needed for extraction, processing, storage, transport, conversion, and transmission and distribution to provide end energy. Carbon dioxide emissions and primary energy consumptions mainly depend on the energy carriers used for electricity generation for this calculation. The Australian electricity mix in the 2011 was used the more and more effectively the use of these energies. Assumptions for heat pump integrations. The assumptions of heat pumps inside the exhaust gas from tissue drying can be used in a heat pump. Thereby, the latent heat content can also be partially recovered due to considered condensation. Heat provided by the heat pump is fed into the low pressure grid under temperature of 160 degrees Celsius. The heat recovery potential was assessed for the humid exhaust gas of one paper machine. The temperature of the exhaust gas varies due to the already existing heat recovery and thus three different situations are considered in summer. The exhaust gas temperature is higher because less heat is recovered for heating in winter, the lowest temperature occurs. Exhaust gas temperature of 80, 65 and 50 degrees Celsius are considered at 65 and 50 degrees Celsius. The humid exhaust gas is fully saturated after heat recovery at 80 degrees Celsius. The saturation temperature of gas is 75 degrees. Results of the heat pump integration. The heat pump further cools the exhaust gas. The outlet temperature of gas is varied in the simulation from 78 to 30 degree Celsius. The heat output of the heat pump increases with the increasing cooling of the gases. There is a steep increase when the saturation temperature is reached and latent energy can be recovered in the below diagram. The heat output of the heat pump is compared to the total thermal energy that is needed for tissue production. Depending on the initial exhaust gas temperature, up to 10 to 55% of the thermal energy can be provided by the heat pump. Finally, going to the conclusion, the case studies show humid, the case studies show the humid exhaust gas streams carry a significant amount of energy that is currently not used. To realize the full potential of these streams, it is important to cool them below the dew point temperature so that condensation starts. For a successful integration of heat pump, suitable heat links are required. The case study of the laundry shows that the humid exhaust gas of the finisher can be used in an efficient way to provide hot water. In a paper mill or laundry, the heat pump can be integrated into a low pressure steam grid. The reduction and reintegration of waste heat streams is an essential step to increase energy efficiency in industry, which is an important step in reaching national and international climate targets. That's all. Thank you. Thank you for watching my case studies. Thank you. Thank you to all.